It's that time of day when we take out our books or pens or pencils and we sit down for another session of learning mathematics conceptually with Mrs. Bentley. In today's video, we are going to be looking at simplifying simple algebraic expressions. And so by the end of this video, you should be able to identify and explain the characteristics of like and unlike terms given any algebraic problem and simplify simple algebraic expressions. So let's get into the video. Let's look at this quick question. It says that Adam has 4 pencils, 3 pens, 3 books, and 1 eraser in his bag. His mother gave him 2 more pens and 1 book. What does Adam now have? To answer this problem, we can start by using graphics to represent whatever it is that Adam has. Then we can use graphics to represent what his mommy gave him. So we know that if we add up all of these things together, we can know exactly how many resources Adam would have. This tells us that he will have 4 pens plus 4 pencils plus 3 books plus 3 pens plus 1 eraser plus 2 more pens plus 1 book. If we consider perhaps Adam's aunt or is daddy giving him some more resources, say is daddy supposed to give him some more books and some more pencils, some rulers, etc., then we can imagine this sentence being a very long sentence. Because of this, we can use our algebraic variables to define the items that were given, and so we can end up with a shorter algebraic expression. Let's look at what we could use. Again, if we're going to use our variables, we can use just about any letter or symbol to represent any resource or item that will be in Adam's bag or that Adam will have. But for this example, I'm going to say let pencils equal P, let pens equal N, let books equal B, and let eraser equal E. Then we can simply say that Adam has 4P plus 3N plus 3B plus E plus 2N plus B. But if we look at this problem, we see that we have 2 N terms. We have 3N and we have 2N. Same way, if we look at the graphics, we realize that we have pens 2 places. If we were supposed to rearrange these things, we can further simplify this expression to make it even shorter. All right, so let's put the pens, all the pencils together, all the pens together, all the books together, and all the erasers together. So now we can say, all right, it appears that Adam has, so we would write back exactly what it is. Just like how we can rearrange it with graphics, we can rearrange it in algebraic terms. So we end up with 4P plus 3N plus 2N plus 3B plus B plus E. Now we are going to go ahead and simplify. When we look at these graphics, what are we seeing? Yes, we're seeing 4 pencils plus 5 pens plus 4 books and 1 eraser. Therefore, we have 4P plus 5N plus 4B plus E. Can this be further simplified? Is there any way that we can group these any further? No. Why? A pencil will always be a pencil and a book will always be a book. There's no way to put them together and turn them into one. Because of that, we have to call them as is. So it will always be 4P plus 5N plus 4B plus E. These P's and N's, these are what we refer to as unlike terms. When we look at our 3N and our 2N, being it that they are pens, they are like terms and we were able to add them. So let's look further at what like and unlike terms are so we can get a better understanding of what we can simplify and what we cannot simplify in algebra. So what are like terms? Or like terms are the same variables. So they have the same variables or same combination of variables. Recall that our variables are the letters and symbols that we use to represent our unknowns. And so for example, if we have 4x plus 5x, we can go ahead and add these two terms because our variables are the same. They are x. However, for them to be like terms, they also need to have the same exponent. What do we mean by that? The power must be the same. The index or indices must be the same. So for example, we have 3y squared minus 2y squared. So let's look at some more example. For them to be like terms, the same variable and the same exponent. So let's look at 4x to the first power plus 2x to the first power. In both of these examples, the variable is an x term and the power is 1. So these are like terms. We also need to remember that 4 raised to the power of 1 is 4. So x raised to the power of 1 is x. So this can be further written as 4x plus 2x. They would have the same variable and exponents. We don't have to write the power of 1. Likewise, 3y squared minus 2y squared. These are like terms. We can go ahead and simplify. Likewise, 6xy raised to the power of 4 minus 4xy raised to the power of 4. So here we have two variables. We have x and we have y. The x variable as a power of 1 and the y variable as a power of 4. So they are like terms. Let's look at this one. 4a squared b plus 3ba squared minus 2a squared b. If we remember or recall, we know that 4a squared b is the same thing as 4 times a squared times b. Multiplication is commutative. So not all the time they are going to fit the problem exactly how we want it, but we have to look to ensure that even if the order of the variables change, then their exponents are the same. So since the a is the one that is squared right through, and the b has a power of 1, then these are like terms. We can go ahead and rewrite it to make ourselves more comfortable if needs be. As we go into our examples today, we will look at one example like this and we'll better be able to see why it is that we say that these are like terms. It's also important to note that our constants are like terms. So we can go ahead and add 4 plus 3 minus 2 or simplify 4 plus 3 minus 2 because these are like terms. Let's look at unlike terms. What are unlike terms? So for them to be unlike terms, they need different variables. That means different combination of letters and symbols. Example, 4y and 5x. We can't simplify this because the variables are y and x. They are not the same. We also need to note that even if the variables are the same, if the exponents are different, they are not like terms. So they must have the same variables and the same powers or exponents. Look at this example. We have 4a squared b plus b squared. The variables b seem to be part of each term, but they're not the same because this one has, the first term has a squared, while the second term has b squared. There we know, and the first term has two variables, while the second term only has one variable. So let's look at some more examples. 4y cubed plus 4y squared. In this one, of course, the variables are the same, but the exponents are different. They cannot be like terms. Let's look at y cubed plus 4x squared. These are unlike terms. How about 6 plus 4x squared? Again, we have a constant and a algebraic term consisting of a coefficient and a variable. These are unlike terms. They can't be further simplified. Let's look at a worded scenario. So Sarah has the following items in her lunch bag. She have 2 snacks, 4 apples, and 3 juice. So if we define our variables, let snack equal s, then we can see she has 2s. Apples equal a, 4a, and the juice equal x, 3x. What does Sarah now have in her lunch bag? For break, she ate the following. What did she eat? She had 1 snack, 2 apples, and 3 juice. We already defined these terms, so we can go ahead and simplify. If we join these together, we will end up with 2s plus 4a plus 3x. To eat the things for her lunch, that's subtract, so she would have removed them. She would have removed s plus 2a plus 3x. We could also have written this another way. If we expanded the bracket, use the subtraction to expand the bracket, we can end up with 2s plus 4a plus 3x minus s because she ate the snack, minus 2a because she ate 2 apples, and minus 3x because she had all 3 juice. If we now group our like terms, we put all the s term together, all the a term, all the x terms together. We can now add and subtract to simplify. 2s minus s equals s, 4a minus 2a equals 2a, and 3x minus 3x means that she would have had all the juice, so she has none remaining. So our answer is s plus 2a. All right, let's look at some more examples. Let's try 2x plus 6y plus 7x. What is the first thing that we will do? Yes, we are going to group our like terms. So we end up with 2x plus 7x plus 6y. Simplify by adding. 2x plus 7x would be 9x plus 6y. Of course, these answers can be further simplified, and we will look at that in our next video. Example 2, 6u plus 3v minus 2u. We group the like terms. We end up with a final answer of 4u minus 3v. Let's look at this other example. We have negative b plus a plus 2b plus a. As per usual, we are going to group our like terms, and then we are going to simplify. But for this problem, if we have minus b plus 2b, some persons are not readily able to understand it, and so we can rearrange it to become 2b minus b plus a, which is the same thing as b plus 2a. Let's look at another example. Negative 3p plus 9q plus 3p minus 2q. Here we have a lot of different signs. We have both positive and negative numbers, and so we have to be careful. We go ahead, we group our like terms. Remember that the signs move with the terms. We can further rearrange to simplify, and so we end up with 3p minus 3p plus 9q minus 2q, which is the same thing as 7q's. Let's look at another example. Let's try this example. Let's try negative 5x minus 3y minus 2x plus 5y. Let's follow our steps. Let's rearrange the terms. If we look at this example, yes, we can rearrange it. We group the like terms first. Then we can rearrange the terms if possible. But we end up with negative 5x minus 2x. What do we do in a case like this? what is our answer going to be? All right, so let's use this number line to try and explain what we should do when we get a problem like that. So if you recall, we had negative 5x minus 2x. To subtract means that we're going to go to the left because we want the number to be smaller, right? So if we start at negative 5, that would represent our negative 5x, and we move 2x in the direction left. Then we ended up at negative 7. So our answer is negative 7x. All right, so we know that negative 5x minus 2x is the same thing as negative 7x. A simpler way of finding our answer is to say we're going to add both numbers and keep the original sign. So we add 5 plus 2, which is 7, and the sign that we have been working with is a negative sign. So we have negative 7x. And if we simplify 5y minus 3y's, we end up with 2y. So our final answer is negative 7x plus 2y. All right, let's look at another example. So we have 5xy plus 4x minus 6yx minus 3x. If we group our like terms, we can say, but all these terms have x variables. So how do we know what the like terms are? Obviously, the ones that only have x would be like terms. But how about those? We have xy and we have yx. Let's simply recall that multiplication is commutative. And 5xy means the same thing as 5 times x times y. And if we wanted to rearrange this, we could have 5y x or 5y times x. So 5xy minus 6yx are like terms. But we can rearrange our variables if we feel more comfortable. We can go ahead and rearrange it because, again, multiplication is commutative. In this essence, we now have negative 6xy plus 5xy plus 4x minus 3x. What's negative 6xy plus 5xy? I mean, even if we rearrange it and we put the 5xy minus 6xy, this could be a little bit of a challenge for some persons. So we're going to again use our number line to simplify this. All right, so we have negative 6xy plus 5xy. So we are starting at our negative 6. So this will be our negative 6xy. To add means that we're going to go over to our right and our number is going to get bigger. So we are going to be adding 5xy. So this is 1xy, 2xy, 3xy, 4xy, 5xy. So our final answer is negative 1xy, which is the same thing as negative xy. All right, so I hope that explained it. So there's a simpler way of getting our answer if we don't have a number line. We can simply say to subtract the smaller number from the larger number and keep the sign of the larger number. So would have subtracted 5 from 6 and would have kept the sign of the 6. So would have ended up with, again, negative xy. We'll simplify the other part of the equation, which would be a positive x. So our final answer should be negative xy plus x. What we have to remember when we're doing algebraic or simplifying algebraic expressions is that we have to call on all the prerequisites that we have when we were using or solving arithmetic. So when we were doing our usual addition and subtraction, especially with directed numbers, we're going to need to remember these rules in order to solve or simplify or algebraic expressions. So this brings us to the end of today's video. So let's quickly recap what we would have done today. So we would have looked at like and unlike terms. We said that only like terms can be added and subtracted. We said that like terms have the same variables and exponents. Unlike terms can have different variables and or combinations of variables or different exponents. And we said that to simplify algebraic expressions, all we need to do is to group the like terms and then add or subtract. So this brings us to the end of today's video. We'll see you at the next video where we will look at simplifying more complex algebraic expressions that requires more steps, such as using the distributive property and simplifying via factorization. So until then, have a wonderful day.